In section 1.9, we are going to be looking at simplifying radical expressions. And the reason this ties in is really with what we were doing the other day with rational exponents. We talked about flower power. And so we were really looking at some radicals. So today we're going to talk about simplifying radicals, adding and subtracting radicals, multiplying and dividing radicals. All of this should be review. But we're going to start with how do we simplify radicals. One key point here is kind of going back to inverses. And this is a side, this is not related to these three right here, but if I asked you to take the square root of 3 squared, we love that because the square root and the square undo each other and we're left with 3. If I asked you to take the cube root of, say, 7 cubed, we'd be left with 7. If I asked for, let's say, the 5th root of 8 to the 5th, we'd be left with 8. And we're going to use this idea as we simplify radicals. If I'm talking about square roots, that means I want 2 of something. If I have a cube root, that means I need 3 of something, and so forth. So I'm going to ask us to look at the square root of 48, and remember, square root is the inverse of something squared, the cube root of 48, and the 4th root of 48. And not all of these should be, by the time we get to pre-calculus, we should not be breaking them all down this way, but you can always go back to this. So we think about a 48, and a 48 can break down into a 6 and 8, a 2 and 24, a 3 and 16. It's really your choice, and I'll leave that to you. I started with 2 and 24. I'm breaking this into its prime factorization. 24 can break into a 4 and a 6. The 4 breaks into a 2 and a 2, and I'm going to circle those, by the way, because those are prime. And the 6 breaks into a 2 and a 3. So the reason I'm going to do that is because now inside my square root I have 1, 2, 3, 4 2s and a 3. Well, we talked about back up here, if you're taking a square root, you need 2 3s. Well, in this case, I have some 2s in there. So if I have a square root, there's 2 squared. And the square root of 2 squared is 2. So I'm kind of bringing out that pair. And then I have another 2 squared. And so I'll bring that out. And then this guy doesn't really have a buddy. So he's going to have, he's going to have to stay inside. I didn't mean to make that little 3 there. Shouldn't be there. You're going to stay inside that radical. And that's it. So 2 times 2 is 4. And then we've got our square root of 3. So it's 4 times the square root of 3. Okay. So now if I look at the cube root of 48, it's still the same prime factorization, but a cube root says we need 3 of the same number. So 1, 2, 3. So I need triplets. The cube root of 2 cubed is 2. What's left inside? There's not 3 of anything, right? Not 3 of the same. So we're going to leave that back multiplied together as a 6. When I go to the 4th root of 48, again, 48 breaks down the same way. But the 4th root says we need 4 of a kind to pull out. So I pull out the 4th root of 2 to the 4th is 2. And then inside that 4th root, we're left with a 3. Okay. So when we have a square root, we're looking for buddies. We're looking for pairs. We have a cube root, we're looking for triplets. We have a 4th root, we're looking for 4 of a kind. Press on. So that's simplifying radicals. Let's review how we add, add and subtract radicals. If you want to add and subtract, they're the same operation. We are going to combine like radicals. We talk a lot about in mathematics combining like terms. Well, like radicals must be the same root. We sometimes call that the index, and the same inside. I'll explain as we go. So let's kind of go back up here for a second. If I said what's 2x plus 4x minus 7x, we would call those like terms because they're all x's. I have 2 of them, then I add 4 of them, so now I have 6, but then I'm going to take away 7 of them, which leaves us with a negative 1x. You can't even see that. There we go. Same thing is going to be true with radicals. I have 2 radical 3's plus 4 radical 3's. Those are like my x's. Those are all like terms because they're all square roots. That's the index. And the same inside. They all have a 3 inside. So I have 2 plus 4 of them, which is 6. But then I take away 1, which leaves us with negative 1 radical 3. And we all know we don't have to write the 1 in front, but I'll take it either way. So in order to add or subtract, they must match exactly, just like variables. When we look at the next one, we have radical 8 plus radical 32. Those don't match. However, let's try to simplify these first. An 8 breaks into a 4 and a 2, and that 4 breaks into a couple of 2s. So I have 2, 2, 2. So right now I have the square root of 2 times 2 times 2. That 32 breaks into 8 times 4. The 8 breaks into 3 2's. The 4 breaks into 2 2's. So inside that square root I have 1, 2, 3, 4, 5. Remember, for square roots we want pairs. So this first piece is 2, and then I still have a radical 2. We have a pair here. We have a pair here, so 2 times 2 is 4, and we still have that radical 2 on the inside. So I have 2 radical 2 plus 4 radical 2. I can add those together because now those radicals do match, and I'm left with a total of 6 radical 2. Good. Let's take a look at this last one. So I have the square root of 20 minus the square root of 300 plus the square root of 45 plus the square root of 27. So, we're going to break this up, and that 20 is the same as 4 times 5, and that 4 breaks into 2 2's. 300 is the same as 100 times 3. That 100 breaks into a couple 10's. And I actually stopped there. I know 10 is not prime, but I see a pair, so we can stop there. 45 is the same as 9 times 5, so 3 times 3 times 5. And then 27 is 9 times 3, and then that 9 breaks into a couple of 3's. So for saving space, I didn't write every single piece out. So again, they're all square roots, so I'm going to take out that 2. So I have 2 radical 5 minus, there's a pair of 10's, so 10 radical 3, plus, there's a pair of 3's, the 5 stays on the inside. And the last one, I have a pair of 3's, but I'm still left with a 3 on the inside. So I have 4 terms, 1, 2, 3, 4. These two are like terms because they're both radical 5's. So 2 radical 5 plus 3 radical 5 is 5 radical 5. And then these two are like terms because they're both radical 3's. So I have a negative 10 radical 3 plus 3 radical 3, which is negative 7 radical 3. Good. Pause when you need to, at any point. I'm going to go ahead and move on. Same thing, we're going to continue simplifying or adding and subtracting these radicals. So when I look at this second one, or this first one here, it's the cube root of 16. So, the cube root of 54, the cube root of 2. So they don't match yet. And maybe they won't, but we have to look. 16 breaks into 4 times 4, and each of those 4's breaks into a couple of 2's. Plus, then I have 4 times the cube root of, the 54 breaks into 9 times 6, the 9 breaks into 3 times 3, and the 6 breaks into 3 times 2. And then a 2 is already prime, so we'll just leave that piece alone. So they're all cube roots, so the indexes match, the roots match. Let's see if we can get the insides to match. It's a cube root, so I need 3 of a kind. So I pull out this group, and inside the cube root I'm still left with a 2. Here, cube root, so I can pull out some 3's. Now, when I pull it out, I'm multiplying, right? 4 times 3 is 12. And left inside is that extra 2. And then this last one, well, there's no group. You just leave it alone. But the good news is they all match now, right? They're all cube root of 2's. Cube root of 2's. Now remember, there's an invisible 1 in front of this one. So I have 2 of them plus 12 of them, which is 14, minus 1, which is 13. So I have 13 times the cube root of 2. Notice I'm being very careful to put my index right in that little armpit of that square root. I don't want it hanging out here looking like a giant 3. So I have 13 times the cube root of 2. Now on this next one, we've got 3 plus 5 radical 3 in parentheses minus 5 minus radical 12. So we know if we're going to subtract, that means we need to subtract everything in there. So we're going to distribute that negative, and I'm going to break out that 12. So I have 3 plus 5 radical 3 minus 5 plus, and then that 12 is going to break into 2 times 2 times 3. Again, by the time we get to pre-calculus, I think a lot of us should just be able to see, oh, 12 is the same as 4 times 3, and we know the square root of 4 is 2. So I don't think we should have to write all of these out. So right now we have 3 plus 5 radical 3 minus 5 plus 2 radical 3. So here's some like terms. I've got a 3 and a negative 5, which is negative 2. And then let's see, these are good. 5 radical 3 plus 2 radical 3 is 7 radical 3. Again, pause when you need to catch up, but I'm going to go ahead and move on and talk about multiplying radicals. I know when we add radicals, they must match. That's just the rule. When you add like terms, they must match exactly. However, when we multiply radicals, they do not have to match. Even think about this. If I had something like 2x times 4y, we're allowed to multiply those together even though those don't match, and we get 2 times 4, which is 8, and x times y, which is x times y. So when we multiply radicals, one thing that has to be true is the index has to match. But then we're just going to put the multiplication inside that house, inside the radical. By the way, this rule works backwards. Okay, we'll be talking, it's actually what we've been doing is we've been using this rule backwards. Okay, so we just put the multiplication under the same radical. So if I have the square root of 6 times the square root of 3, I'm going to write that as the square root of 6 times 3. Now notice I didn't call that 18. Why? Because the next thing we're going to do is break it down, and it's already a little bit broken down for us. So let's break that 6. 6 is 2 times 3. I mean, if we're going to simplify our answers anyways, so we said put the 6 times 3 inside, and then I broke up the 6, and now I see that pair. So I have the 3, and then the 2 stays on the inside. So the key with multiplying radicals is you just do the multiplication inside the radical, but they have to have the same root. Same thing with this one. I've got the square root of 14 times the square root of 28. I don't know what 14 times 28 is, and even if I grabbed a calculator, I wouldn't want to do it, because then the next thing we're going to try to do is break it up. So we put the multiplication under the same radical, and then I start breaking things up. The 14 breaks into a 7 and a 2. The 28 breaks into a 4 and a 7, and that 4 breaks into a couple more 2's. Now it is a square root, so I'm looking for pairs. In fact, I have a pair of 7's to pull out. I have a pair of 2's to pull out. But then left inside, we still have that single 2. So we have a 14 radical 2. I'm not saying that that was the most efficient way to do it. By the way, I could have said, oh, 28 is 14 times 2, and then I would have seen my pair of 14's to pull out. Okay, lots of ways to do this. All right, let's take a look at the next one. We've got the cube root of 25 times the cube root of negative 10. First of all, can we even take the cube root of a negative? And the answer is yes, because when you multiply an odd number of things, you're going to get a negative. Well, if you multiply an odd number of negative numbers. Square roots, we cannot take the square root of a negative. Fourth roots, sixth roots, no. But any odd root is absolutely fine. So let's break this down. They're both cube roots. That's important. In fact, I'm going to take that -1 and break it off. 25 is 2. So it's a cube root. So I see my group of 3 to pull out. I know the cube root of -1 is -1. So I'm going to pull out a -1 and a 5. And inside that cube root is that lonely little 2. Again, coincidentally. Okay. So that's not a 1.5, that's a -1 times 5. So I have -5 times the cube root of 2. Okay. All right, let's take a look at the last one. I've got the cube root of 18 times the square root of 2. Can I multiply those together? The answer is no, not right now, because one's a cube root and one's a square root. So I'm going to say not possible. Roots don't match. Okay, so just be very careful with that. Good. I'm going to flip it over. Pause if you need to. So let's talk about binomial radical expressions. Binomial radical expressions. Remember, binomial means 2 terms. So I have 2 terms being multiplied by another 2 terms. That's what makes it a little bit different. But we already know how to multiply binomials, right? We're going to FOIL. If I asked you to multiply x plus 1 times x minus 3, you'd FOIL. When we multiply binomials, same thing. So 1 times 2 is 2. I go to the outside. 1 times radical 6 is radical 6. I go to the inside. -2 radical 3 times 2 is -4. Wait, do not hesitate to go over to the side and do some of your arithmetic off to the side. -2 radical 3 times 2, remember there's a multiplication symbol in there. And we are allowed to multiply in any order. So let's multiply these 2's together and then tack the radical 3 at the end. That's where I got that from. And then my is a positive. In fact, I'm going to write this one up to the side. I have a -2 radical 3 times a radical 6. The 2 stays there, the -2 stays there. Radical 3 times radical 6. Remember the 3 and the 6 go on the inside? I actually think we did this back here, didn't we? Didn't we already say radical 6 times radical 3 is 3 radical 2? So let's not rehash that. Oops, sorry. So we already got this from the front. So we have -6 radical 2. So now I'm going to go try to simplify that. I'm going to see if I have any like terms. There are 4 terms. This is a radical 6, and a radical 6 breaks into a 2 and a 3, but there's no pairs in there, so there's nothing we can do. So guess what? We're done. Those are non-like terms. Let's take a look at this next one. I have 4 minus 2 radical 5 quantity squared. Remember, if we're squaring something, that means you're going to multiply it by itself. And now this problem is like the one we just did, just different numbers. So let's FOIL. 4 times 4 is 16. 4 times -2 radical 5 is -8 radical 5. Do the insides, we get the exact same thing. We'll combine those in a minute. And then we go to the end. A negative times a negative is a positive. And I want to do 2 radical 5 times 2 radical 5. Again, we can multiply in whatever order we want. So I have a 4. And then radical 5 times radical 5 is, well, we put the multiplication inside and we get 5 squared. It's just 5. Just 20. So let's look for our like terms. I have a 16 plus a 20, which is a 36. I have a negative 8 radical 5 and another negative 8 radical 5 for a negative 16 radical 5. Again, we're combining like terms there. So when I combine these, the radical 5 doesn't change. I'm not multiplying these together. I'm subtracting them. All right. Last thing we're going to talk about today is dividing radicals. But by the way, division and multiplication are essentially the same thing. So the rules should be very similar. If you are dividing two radicals that have the same index, you can put them underneath the same radical, and vice versa, right? You can, if you have a fraction inside. All right, well, here we go. I have the square root of 40 divided by the square root of 2. Well, we can put that into one giant square root. So now I have the square root of 40 over 2. The square root of 20, well, 20 breaks into 4 times 5, or 2 times 2 times 5. Got a pair of 2's to pull out, and so my simplified answer is 2 radical 5. This next one, we're dividing cube roots. Cube root of 32 divided by the cube root of 4. Again, the division 32 divided by 4 can go under that one giant root. And we know 32 divided by 4 is 8. Now, I honestly think we should know this one. The cube root of 8 is 2. And I highly recommend you memorize that, because we're going to see it a lot. Not that you can't work it out, but you're not going to want to spend the time to work that out every single time. The cube root of 8 is 2 because 2 cubed is 8. All right. Let's take a look at these last two here. Last slide. Now, we have the square root of the fraction 4 over 49. If, I'm going to slide this back for a second. There we go. We can use the rule backwards. If you have a fraction inside your root, you can break it into two radicals. And that's exactly what I'm going to do here. 4 over 49 does not reduce, or I would have tried. So I'm going to break this into the square root of 4 over the square root of 49, which those are perfect squares, and we get 2 over 7. Good. And let's do the last one. You've got same kind of idea. Now it's a fourth root. 8 over 81 does not reduce. So I'm going to split that into the fourth root of 8. Now for a second. And 8 breaks into 3 2's. In the bottom, I'm just seeing if this simplifies. 81 is the same as 9 times 9, and each of those 9's breaks into a couple of 3's. Now, on top, it says I need to have 4 of a kind. I don't, so I can't simplify that. So we're going to leave the numerator as the fourth root of 8. There's nothing we can do. But on the bottom, we need 4. Oh, perfect. So on the bottom, the fourth root of 3 to the fourth is 3, and there's nothing left in the radical, so it's gone.